Yes, maybe if we have 5 minutes for this question. In fact, in my test environment, I was asked to uh, monitor some host, some SNMP agents from the minions. Uh, and the minions, of course, forwarding the alarms to OpenNMS core via Kafka bus. So in fact, I will not monitor from OpenNMS core, right? I will monitor from this will be delegated to the minions. So I just wanted to have some tips, some hints, to uh, to ease my work when I will configure the minion. I don't know if I can configure them via the UI. It's OpenNMS UI itself or not. Some stupid question like this.
Okay,
How
all right,
can
we'll
I
cover
ease
that.
my life?
That's fine. We can do that. We'll do that pretty much straight away. Anything else? Anybody else?
Hello, everybody. I have other questions related, very stupid, maybe very quick, that is related to the actual way to configure services that are activated or used at the moment you load the requisition. For example, we see that the default are CMP or SNMP, but for example, if I want to exclude one that I know that it fails, my project I have ECMP is not enabled, for example. How can I configure the actual services that I want to use?
Okay, so we will cover that today in the example.
Okay, thank you.
That's fine. That will do. Okay, so let me just start by just saying where we're at in terms of the session. So let me see. Right. So we're on session 7. And can you see my screen? I should have session 7 on it.
Yes.
Okay. So what we're going to do today is we're going to look at how to set up OpenNMS behind an Nginx server so that we can terminate HTTPS. But we're also in that context going to look at how we set up a minion, because that's what we've just asked. And we will look at business service monitoring. Okay, so let me start off, and also I do want to look at Grafana as well, because that's something that we haven't covered. Okay, so let me start off with the minion. In this particular example, and this is more or less the same as the previous examples, you can see that we have the database, we've got Horizon, and then we've got the minion here. Okay. Now, the minion configuration comes from this minion config.yaml. Okay, which gets injected into the minion. Now, let's have a look at that.
It's Craig, is the same logic, I guess, for cloud environment, because I'm running the Minion and the OpenNMS core in Kubernetes rancher
It
platform.
is. So the containers are exactly the same. So
Okay.
you'll have to inject this data using Kubernetes, but the actual configuration is exactly the same, because the containers are the same.
Okay.
So you'll see here a YAML file that defines basic information for the minion. Now, in this example, I am using ActiveMQ. Okay. So here we've got the broker URL for ActiveMQ. That's basically running in Horizon. So it's basically saying, please use this ActiveMQ server in Horizon. Then you've got the minion ID and you've got the minion location. Now, the thing to remember is that whenever the minion starts up, it registers with OpenNMS. It doesn't wait for OpenNMS to talk to it, because the minion could be behind a firewall. It may not be possible for OpenNMS to see the minion. The minion has to initiate the conversation. So what the minion does when it starts up is first of all, it tries to connect to the broker. And once it's connected to the broker, it will then announce its presence to OpenNMS. And when it does that, it says, I am minion, and it gives it the name that it has for itself. And it also tells us its location. Now that's important because you can have more than one minion in a given location. If you want to use minions for load balancing or as redundancy, then you could have two minions in that location. But OpenNMS would know that they were both in the same location. So that's how the minion is set up. And then there's a bit of other information here in terms of where the trap's going to be sent. What's, the minion's going to be listening on port 1162 for traps and 1514 for syslogs. And if you were setting up the minion to do other things, then it would, have other ports open to receive other information. But that's basically how the minion is set up. Okay. Now, if I just go back to Horizon, and again, this is all covered in the docs, but this example shows you how it's set up. You can see that we have this file here, OpenNMS ActiveMQ, which again is injected into the etc. directory. And again, if you look at the documentation, they'll explain how to do this. This ActiveMQ stuff is pretty standard. It's the standard ActiveMQ configuration. But essentially, and I can't remember exactly what it is, you have to uncomment a number of lines in order for the transport connection to work on ActiveMQ. So this is the information here. You can see it's going to listen on port 616, and that needs to be uncommented to allow localhost TCP connections.
And it's also the same logic for Kafka.
Yes,
here we are using the ActiveMQ, but probably the same logic for Kafka, right?
Yes,
we need
exactly.
to uncomment some lines if we want to configure with Kafka.
Yes. So again, if you go to the OpenNMS documentation, we'll just look at that one. Minion.
And this ActiveMQ, is it working like a separate process on the core?
No, or... the ActiveMQ is working in OpenNMS. So that's just provided as a for small deployments. Then you could just run ActiveMQ as part of OpenNMS. But in larger deployments, you'd run a separate ActiveMQ server. You can see
it will be like a minion or just a separate process.
I'm sorry, say it again.
ActiveMQ will be like a minion on a bigger deployments, or it would be like just a separate process somewhere.
In a bigger deployment, ActiveMQ would be a separate container. So you'd have ActiveMQ running in its own container. Okay. But in this example, we're just running ActiveMQ locally in OpenNMS.
Okay.
And then the instructions are here for setting up the minion. And you can see, this is how you do it for Kafka, for ActiveMQ, or if you wanted to use gRPC. And I've just done the ActiveMQ configuration.
Craig, in ActiveMQ file, I noticed administrator credentials. So does it mean if we'll change admin account from the GUI, we have to update it manually in ActiveMQ file? ActiveMQ XML file.
The ActiveMQ file, anything credentials in the ActiveMQ file are just specific to ActiveMQ. They're nothing to do with OpenNMS.
Because I noticed there is a user admin and password admin in it.
Yeah, possibly, but it's only for the purposes of ActiveMQ itself. It's not for OpenNMS. Okay. I mean, I honestly, I'm not. I've just got enough here running so that you can see it, but there's obviously more detail behind this if you really want to use this in Anger. And again, you would need to look at the documentation. But in your case, you'll be running with Kafka. And I just used ActiveMQ because it was simpler for these experiments. But for Kafka, it'll obviously be, more to do.
Yeah, Kafka is probably more appropriate for production environment, I guess.
Well, ActiveMQ is fine in a production environment, but you would definitely use a separate ActiveMQ server.
Okay.
But Kafka is the flavor of the month. Before that, ActiveMQ was, everybody used that. So, it's horses for courses. It doesn't really matter. Both work well.
Mm-hmm.
Okay, does that answer the question on the minion?
Yeah, just to be back one sec on the config for minion. Let's suppose that I want my minion to monitor some address, some network address range. Where should I configure the network address range? I can do it from the UI itself, or only from config YAML file.
So all that configuration in the YAML file does is tells the minion how to talk to OpenNMS. It doesn't tell the minion what it's monitoring. Okay. OpenNMS will tell it that. So if we look at the provisioning requisitions, first of all, these minions here, okay, they whenever the minion registered itself, it showed up here. Okay. So as you add more minions, the minions will automatically register themselves and show up in the requisition. Okay.
Okay.
Right. That's the first thing. So the second thing is, if we just look at this example here, for instance, if I wanted to change the location at which something was being monitored, I would put it in here. Okay. So if you remember, if we go back to, better to go to the test network. If you remember the test network, these particular SNMP examples were running, actually being monitored by core. But this one here was being monitored by not by core. Okay. So if I look at that, you can see it's being monitored by the minion one location.
Okay. And
so that's how you set it up. You basically, once the minion's been registered in OpenNMS, whenever you set up the provisioning requisitions, you can tell it, monitor this particular node from this minion location. And then the IP address that's used can overlap or can be in a different segment than the OpenNMS system.
I got it. I got it, Craig. But let's imagine one thing. I have two minions. Minion one will. I want minion one to monitor subnetwork A, so some address range corresponding to subnetwork A, and minion two to monitor subnetwork B. So how can I configure from the UI my two minions?
You have to put the minions in different locations.
Yeah. Okay. Different locations. Okay.
Yeah. And because OpenNMS doesn't know which minion's actually doing it only knows which location is doing the collection.
And okay. And from the UI, from which place can I enter the address range the minion is supposed to monitor?
Well, if you remember when we did so if you remember, we went back and we did scanning of the network.
Yeah, I have an address range from one address from starting first address to the last address, and I want the minion to discover, let's say, this address range and to automatically register the discovered nodes and make these nodes monitored by the minion, of course.
Yes. Okay. I can't remember where they. Let me just do it. Right. Okay. Look. Remember when we put in the include ranges? Okay. The IP addresses.
Right? Yes.
Yeah, right. Yeah. The location is what you say where that address range is going to be scanned.
Yeah.
Right.
Right.
Which minion is in which location depends on the minion, okay? All we can define here is that we want to scan this address range from this location.
Okay.
All right.
All right. And
then if you've got two minions, you need to put them in two different locations.
Sure.
And then you would specify this particular location is going to do this range, and this other location is going to do this range.
Okay, Craig. And after saving this config from the UI, can I offline? Can I have a look at a config file where this configuration will be stored, or is it stored only in the?
Yes. So again, we covered that back in session 2, where I showed you that there is a configuration file. It's an XML file that's backed by that UI.
Okay.
If you remember that. So we go back, I think it was session 2. Yeah. Let me just see. We're going to scan that range.
Yes.
Right?
Now I remember. Yeah.
So
it's an XML file. Yes.
There is a file. I can't remember.
XML, right?
I honestly don't know where it is, right? But there's a file that backs this up, okay? And if you put that file into OpenNMS, then it will use that, okay? Because that's just driven by the UI.
Okay. Thanks, Craig.
Okay. Sorry, I can't find the exact.
No, that's okay for me.
Here
we can have a look offline, outside from the UI.
Yep, that's fine. Okay, good. Okay. Hopefully that's covered. I mean, we have covered this before, so it's just reminding you of stuff we have covered. So the material is there somewhere. Right. So let's go back to this example. What we wanted to look at was how do we put OpenNMS behind a proxy? Okay. And just to show you that this is working, I'll jump to my UI in a sec. So this is my Docker Compose. And you can see here, I've added in an Nginx in front of the OpenNMS, okay? And this is just a standard Nginx configuration. Now it's using self-signed certificates. If you want to use Let's Encrypt or stuff like that, well, you've got to work that out yourself. This example doesn't cover that. All this does is it injects self-signed certificates. So if we look at the Nginx configuration here, there's a bit of information here on how to set up the private keys and stuff like that, but useful, but I'm not going into any detail. You can see that I've actually created a local host certificate here, but it's a self-signed certificate. You would have to put your real certificate in here if you wanted it, to be fully secure. And if you wanted to use Let's Encrypt, there's lots of examples online of using Let's Encrypt of Nginx. Confd basically is a configuration for Nginx that sets up OpenNMS behind the proxy, and basically what we're doing is we're forwarding all traffic to port 443. So if it comes in on port 80, it'll go to 443, and then under 443 we've got a proxy for Grafana and a proxy for OpenNMS, and then there's various different configurations here. Again, it's all covered in the documentation on OpenNMS. But this basically forwards the proxy information to OpenNMS. So that's what you need to do in Nginx. And then you also need to make a change in OpenNMS to allow it to serve up the page properly. And in this case, it's in the etc. directory under OpenNMS.properties-d. And basically, we just need to add in this extra property, web-based URL equals HTTPS. And that means that the OpenNMS UI is going to send back the HTTPS rather than HTTP, and it'll redirect properly. So that's what you need to do. So you put that extra property into OpenNMS, so it knows it's behind a proxy. and then you set up the proxy itself so it'll work. And if I show you what it looks like, this is my little Nginx server. You can see it's running, just giving me a simple little page. And then if I click on the link, it'll take me to OpenNMS, and you can see I've terminated HTTPS here. And if I click on Grafana, it'll take me to Grafana, which we'll talk about in a little bit. Okay. Any questions on that? Because I know people were asking about this before. Okay, right. So that's how you put OpenNMS behind a proxy. What I wanted to do also now was I wanted to take the data collection a little bit further, just to show you some other stuff you can do with OpenNMS. And what I want to do is show you how you can use OpenNMS to monitor Nginx itself. And you could do a similar thing with any other web server. Nginx can produce this status page. So if I click on the Nginx localhost Nginx status, you can see it's got active connections and then accepts handled and requests, accept handled requests, and a bit of other information on what's reading, what's writing, what's waiting in terms of the processes inside. Again, look at the Nginx documentation. It'll tell you what these things mean. But you can see as I make more and more requests, the numbers go up. So it's actually counting the number of requests that are happening as they happen. Now, what we want to do is to get OpenNMS to use this information to create some graphs based on Nginx data that we're receiving. So we want to be able to regularly go out and make a REST call against Nginx, pull this information back, and parse it into something useful. Now, if I go back to my example, I want to show you how that is done. Again, Ronnie may or may not have covered some of this yesterday, and I'm not going to go into in terrible detail, but I want you to at least have an idea of how it is done. So the first thing is we need to set up collectd to recognize this Nginx service. And collectd has got, it's able to collect information on lots of different services out of the box. And you can see there's different things. Now, each of these collections corresponds also to a collector service, which uses a different class. So we're using the Prometheus collector to get data from Windows Exporter, for instance. We're using the XML collector to get stuff from Elasticsearch. We're using the JDBC collector to get information from Postgres. These are different collectors. And again, if you look at the OpenNMS documentation, the collectd process will use whichever collector has been configured for that data collection. Obviously, SNMP, Ronnie's covered that, but this is able to collect data from other sources using REST, or in the case of the OpenNMS JVM, we're using JMX. So what I've done here, I've added in 2 extra services. One that allows me to collect Apache stats, which I'm not going to go into, but the examples here in the code, and then the other using Nginx stats. And in both cases, I'm using what's called the HTTP collector. So let me look at the collector itself.
So here the goal, Craig, is to do a self-monitoring of the OpenNMS platform?
Yes, well, to monitor an Nginx server. So yes, you'll be monitoring part of that information. So in this case, it is definitely about getting that information. Why am I not? So this is the documentation on the HTTP collector. The other collectors are all, documented here. You can look at them. And you can see, this gives you all the information about how to do it, but I'm just going to go through the example very simply. So let me go back to my example. So I'm using the HTTP collector. I'm using for Nginx stats. And here is the Nginx stats data collection config. And it's saying that, you know, I'm going to collect 30,000 milliseconds. That's every 5 minutes. I'm just going to retry once. And if the thing doesn't respond, I'll wait, 2 seconds, I think, basically. And if it doesn't respond after that, we'll just say, well, we haven't collected any stats. We'll move on and we'll try again in another 5 minutes. But you could retry more often and you could have a longer timeout if you needed. So that defines the how often we're going to poll, and it defines which data collector we're using. The next thing we need to do is we need to look at how that HTTP collector actually gets configured, and it gets configured in this file, HTTP data collection config. And there are, various different examples here. I'm looking specifically at this Nginx stats example. And remember, this is what we're picking up here: active connections, server accepts, reading, writing. So what happens is that the data collector will go out to our URI, and in this case, the URI path is Nginx stats. And it's going to use a regular expression to match the response. So as long as we get a response range in between 100 and 300. So we're basically, what it's saying is, as long as the server's responding, probably with a 200 code, then we're going to look at the data that comes back, and we're going to use this regular expression to match against. Now, what then we do is we actually create these attributes based on the match group. Now, this is the complex bit. Obviously, you have to have a bit of, it took me a long time, right, to work out what the regular expression should be. And I'm not going to do a tutorial on regular expressions because, it's too complicated even for me to understand. But there are tools online that allow you to test your regular expression. And, you could basically put the text into the tester.
You have a good tool. You have a good tool to suggest for that.
I do, and I will find it for you after this. I'm sorry,
okay.
I haven't.
Okay. I mean, Craig, we have the same concern also for threshold settings for performance for a regular expression. If you have a valid tool that you use.
Okay. I will. I'll point that to you. In fact, I mean, I can show you what it is in a minute, but tools are available. So anyway, this does the capture, and it captures up all these 7 groups. Okay, and those basically are the values corresponding to the numbers that you see in the response here. So then what we need to do is basically say, okay, well, these are the stats that we actually care about. And some of them are counters and some of them are gauges. Counter basically will continuously go up, whereas a gauge can go up and go down. So for instance, the number of processes that are waiting and writing, are going to go up and down. They're not going to count continuously, but the number of requests is going to go up. So that's obviously a counter. So that's how you capture the data. So if you've got this configuration in there for the data collection, it will scrape the response. It'll create these matches, and I'll put the data into OpenNMS. So the next question is, how do we display that? And in that case, what you have to do is you have to create a graph corresponding to the data that you've got there. And I have an example here, nginx graph.properties. Again, you need to look at RRD tools documentation to help you understand how these properties work, because it's an RRD tool feature. It's not an OpenNMS thing specifically. But essentially, and I'm not going to go into this in detail because I'll just get myself confused, what we're actually doing is we're putting in the labels for the data that we want, and we're telling RRD where it's going to get that data, and we're telling it how it's going to display the data in terms of the colors and stuff like that. And so if I actually go to my OpenNMS, Sorry. And I go to the node. Now, what I also need to be aware of, and this will come to the other question that you were asking, was how do we set it up to actually monitor that service? So again, if I look at my requisition in this case, you can see that I now have an Nginx server at port 005. And I look on that, and you can see that under interfaces, I have configured an Nginx stats interface here. Now remember, there was also, I think, a definition for Apache. So if I could add another service, and you could see there's Apache stats. So I could say I want to collect Apache stats against this. Now, obviously, that would be ridiculous because we only have Nginx here. But the point is that once you've defined the data collection, it will show up in this configuration as something you can choose.
Like a node, right?
Yes. The node is Nginx. What we're specifying against the interface is what services are on it. And in this case, we're specifying the Nginx stats are going to be on that interface.
What is the meaning of SNMP primary always present?
That tells us that the primary interface for collecting SNMP is this interface.
So is a sort of privileged service SNMP?
No, it's saying that if SNMP is found on this interface, this is the primary interface for collecting SNMP. You can set up another interface as secondary. So if it fails to collect from the primary interface, it will go to the secondary interface. And you can also set up that you don't collect SNMP. So again, if you put in, I think it's, I can't remember what the value is, but I think it's N or something like that. It'll say, don't try and collect SNMP from this interface.
Okay. Okay. So it's possible to exclude.
Yes, you can say some interfaces, you know, mostly devices, you only have one IP address you want to collect SNMP from.
Okay. But even this is true also for the SNMP. But of course, there are cases where it's not enabled. Okay.
All right. So anyway, that's how you do the Nginx. And that is obviously on the UI. But
if we will get the data from it like in SNMP traps, right?
No, this is SNMP data collection. So SNMP traps will come in as a trap to port 162. And OpenNMS will deal with any traps it receives. This is about collection. So if I'm going to collect SNMP data, this is specifying which SNMP, which interface on a device we should use to collect that data.
But we're not collecting SNMP data from this Nginx.
No. So it won't find SNMP on this device.
So it can be excluded.
So it shouldn't, it shouldn't be primary here, right?
Well, it doesn't matter. I mean, it won't do anything if it doesn't find SNMP.
Okay.
That's correct. But I think that if it's being explicitly excluded, it's less confusing, right?
Well, it's up to you. It's your decision what you want to do. Okay. I tend to just leave it. So anyway, if I just show you the configuration again, the imports here is the actual configuration test network. And I think it's, where's the Nginx? Here we go. So Nginx. So the configuration is basically saying, you know, this is the IP address, and I want to pick up Nginx stats. So if I use the provisioning requisition, this is how I would tell it what services I want to run on the port. And obviously Nginx stats is something that I'm going to collect. Okay. So again, let's go back to OpenNMS. Let's look at the nodes. We can see that we've got our Nginx node here. Now, when it says not monitored, it's basically not monitored because we're only doing data collection for Nginx stats. We're not monitoring the Nginx stats service. That would be another thing to set up in the polling, but I haven't done that. In this case, we just recognize that we have Nginx stats we're collecting. So under the resource graphs, node level performance, graph selection, you can see that the graphs here with the various bits of data. Now, I have to say that these graphs are not set up right. You know, again, it would take me a fair amount more work just to get this right, but you can see the graph is there. You can see the data is coming in. The active sessions number seems reasonable. The handled requests, obviously the way that this is displaying is, you know, it's got all the wrong numbers on it. So I'm not going to claim that my SNMP, my RRD graph definition is correct for Nginx. That's a bit more work that's required to get that working. But at least you can see that something is being displayed, and you can obviously go and fix it if you've got a bit of time. And that might actually be quite a good exercise to work out, you know, how to do this, how to display it properly. Okay, any questions on that? Okay, let me go back to my example. Sorry, I've lost myself there, so I just need to find the example again. Okay, so we're on session 7. So what we've done is we've put OpenNMS behind the Nginx server, and we're monitoring the server itself to see its response. You know, that's really it. The next thing I wanted to look at was Grafana and how to use Grafana to display information that we need to display. So again, on my Nginx, I can just jump to Grafana. And this is my login for Grafana. You'll see that the password is mypass. And I'll just, in the Nginx configuration, I think it's, it's not there. What it is the Docker Compose. Under my Grafana configuration, which is here, you can see that the password is set up actually here. Now, clearly, this isn't very secure, right? But that's how you do it. You pass in that property to give it the admin password. And then when you log into Grafana, you'll get that password. In my case, I'm already logged in, so I didn't need to enter the password. Okay. And this is just a standard Grafana configuration. The one thing that is added into this is we've specified that we want to load the OpenNMS plugin for Grafana, and that's going to be loaded up, you know, as part of the thing here. So you can see GF install plugins OpenNMS app. That's the plugin that we use, and that's what we're specifying in terms of the plugins we should, you know, run with Grafana. So here's our Grafana. We've logged in. And the first thing you would need to do is you'd need to set up your administration for your plugins. Mm-hmm. And sorry, let me go to connectors and look for data sources. And I've got 2 data sources here, but if I wanted to add a data source, then I would specify where I want to get that data source from. And within this example, you'll see down at the bottom, we've got 3 data sources, potential sources: entities, flows, and performance. So entities will get alarms and events. Performance will get performance data. If you've got flows working in OpenNMS, the flow dashboard will work here, but I don't have that in this example at all. So in order to add a new data source, you basically need to select which one of these you want to use. I won't do that because I've already got one configured. I'm going to look at this OpenNMS performance, and I want to look at that configuration. So when I set up the configuration, I give it the URL of OpenNMS. Now, remember, Grafana is running within Docker Compose. So I tell it that Horizon is where I'm getting this data from. And it doesn't need to be HTTPS because it's not in front of the Nginx. It's behind the Nginx. So Grafana is running behind the Nginx, and I can talk to Horizon directly, and that's the URL it needs to go to. I'm going to specify my credentials, and what I've done is, in this case, I've just put in admin. Now, usually what you would do is you would set up a REST user in OpenNMS, and you would specify a username and password for that REST user. And it would be specifically for Grafana to talk to OpenNMS, and you wouldn't allow it other privileges. It would just be the REST API that you'd be setting that up for. But in this case, just to get it working, just for simplicity, I'm just using the admin password, which will allow me access to the data. When you've put that data in, save and test, and if it's talking to OpenNMS, it comes back with success, and we're happy. So we've got our data source defined. Our next thing then is to look at our dashboards. I've got a little test dashboard here I've already pre-configured, but what I'm going to do is just create a new one. Okay, I'm going to add a visualization, and I'm going to use the performance data source. I'm just going to call this test panel 2. Okay. Now that this visualization in this case is going to be a simple graph. Obviously, you can choose other visualizations, time series, bar chart, blah blah, whatever you want. This is all Grafana stuff. But how do I use the data source? Well, when using the OpenNMS performance data source, which has already been set up, I want to choose what data I want to display. I'm going to choose an attribute. And I'm going to select a node. Now, you could template all of this, in which case you can also do queries as using the entities plugin to actually get nodes. So you can choose which node. You can have drop downs for which nodes you want to display and stuff like that. But I'm making this very simple. I want to select a node, and I'm going to select Netison MP2. Then I want to select a resource on that node. And let's make this a bit bigger. And what I'm going to do is just select the, well, I'll just look at response time because that's simple. Now the attribute then is just ICMP. So it's ICMP response time. You can see straight away, I've now got data showing up that shows what the response time is. And that's basically it. That's the definition of a display. You can, save this, and you'll see that's that. So again, multiple, things can go on the display. Now, there are some other things that are worth just talking about in terms of how this works. Just going to edit this again. I want to actually see if I can create a second metric based on the first metric. The first metric is my response time. Let me just create a second metric now that's going to be a value response time. And let me just put in a series label. Let's call it response 1. So that's my response 1. That's my green. I'm going to create a new example, but in this case, I'm going to use an expression. Now, an expression is a calculation based on other data in our system. And I'm going to base my expression on response 1. And I'm going to multiply it by 10. Why I would do this? No idea. But it just gives you an example of what you can do. Okay. And I'm going to call this response 2. So now what we've got on our graph is the original data. We've also got our data multiplied by 10. But you can be quite sophisticated in this expression. You can include multiple different labels if you've got different labels. You could even include labels from different devices if that made sense. And you can actually use previous time series data as well. So T-1, T-2, T-3. So you could construct an average, for instance, using the expression. And that will, generate the example. Now, if I look at the query inspector, I can actually see the query that's been sent to do this. This is a response. And this is the JSON. And this is the query. Okay. So this is the query that has been sent to OpenNMS to the measurements API to get that data. So people were asking about how does the measurements API work in OpenNMS? Well, this gives you a really good example because what Grafana is doing is it's using the measurements API to get the data that it's displaying. And you can see here that the request basically against that API is getting the measurements, start time, end time, step is how many, the step between the measurements, maximum number of rows, and then the source, object, attributes, and then the expression. There's no expression in this case, but further down there is a another expression that's let's have a look at that to see what it is. Yeah, there we go. That's the expression, response multiplied by 10. So what this is doing, this is the actual request that is sent to OpenNMS to that URI with these filters associated with it to actually pick up the right node. And then the response coming back is this array of 73 data points that are then going to be displayed.
Who is doing the request? Or OpenNMS itself or Grafana?
Grafana is doing the request. So the OpenNMS performance plugin for Grafana turns the Grafana dashboard request into the request to OpenNMS.
Okay.
And then it's getting response. So if you were just using the REST API in OpenNMS, let me jump back to OpenNMS and under help API documentation, you'll see there's various endpoints here. Hopefully it'll come up.
If we are back to your previous Grafana dashboard, we were getting responses from a specific node, if I will remember, 172.0.2.
Yes.
What is this node? This node is one node monitored by OpenNMS?
Yes.
Or is it OpenNMS?
So remember, whenever I specified the node, I said I wanted to use NetSNMP.
Yes.
That was the node name. So that will give me the IP address of the node. And
the resources from this node is something which is discovered
yes,
by
that's right. So
OpenNMS.
Again, Ethernet port 0, I'm looking at the response time for that Ethernet port. That's why the IP address is there, because I'm pinging that IP address basically and getting the response time. But there's other metrics I can pull up here in terms of the disk utilization, whatever NetSNMP exposes. Basically, all of this data is available. Physical memory, shared memory, cache memory, CPU utilization, all that sort of stuff. We could use any of those metrics and it would display those metrics.
So we can eventually try to correlate, in fact, this performance data coming from that particular node to the SNMP alarms that we can collect from the OpenNMS UI. Maybe we can try to correlate the two data, the two graphs, in order to
Yeah, I mean, you could have the two graphs up at the
troubleshoot.
same time, and you could select a time series that allowed us to see that. Let me save this and.
Because I guess if we collect critical traps from that node via OpenNMS, we can also imagine that as a result, this node is in a bad shape, and probably we can see from the Grafana dashboard some indicators showing up that it is really in bad shape.
Yeah, that's right. But again, it's up to you how you display this. No, I'm just doing this on the fly, so it may not work. In this case, I'm using OpenNMS entities, and I'm going to select alarms. So I'm selecting the alarm tables. Well, I could pick a lot of things, right? But where severity is, and I could select which one I wanted. I don't really care, to be honest. I'm just going to get rid of that. False. Okay, so these are alarms where it's false. Okay. And I'm hoping this will work, but it may not. Okay. Should actually be getting a list, but in fact, let me have a look and see. It's possible that I've actually got no alarms here. Yeah, so I've got no alarms, so that would be why. All right, so let me create an alarm, and I'm going to send a trap in, and this is going to be against camera 004. So again, based on what we did previously, that's cleared. So I don't care about cleared. I want to send a raise. Let me do that. There we are. Now remember, we created two events here because one is the actual event against camera 4, and then the camera controller is just going to pick up all of the other events anyway. That's what we did previously. But anyway, camera 4 got this alarm. If I look at my test dashboard in Grafana, whichever one it is, this one here, let me refresh that. And there we go. That's the list of alarms.
Oh, okay.
Okay.
Okay, so now we have two UIs, Grafana and OpenNMS.
Yeah, that's the whole point, right? The whole point is that you can create dashboards for individual users that contain whatever information you want, and you can filter and sort on that and say, I have an end user that is only interested in these particular nodes, so I can create a dashboard specific to their needs, and I can provide a UI view of for them to see.
And the Grafana OpenNMS data sources are provided by the OpenNMS kit. No need to install something from the external. Okay.
No, it's actually contributed to Grafana. So it's a standard plugin that Grafana provides. If you download Grafana and install it, then that plugin's available for you to download and use. Grafana community. Okay. But in my example, I've actually made it easy for you. So basically, follow the example stuff here. For setting up the container, and it'll just work.
Okay. Okay.
Okay. So that was Grafana. There's obviously, Grafana is a world in itself. There's lots of stuff you can do with Grafana, but I just wanted to show you how easy it is to connect Grafana to OpenNMS and get something working. Obviously, you'll learn more as you play with it, but there's a lot of power here. And what we do recommend is for, in situations where you've got a service provider and they've got lots of end users and they want to provide data to those end users, use Grafana as your front end, and don't show them the OpenNMS UI. Just provide them a dashboard based on Grafana, and then you can template that, and you can have, dashboards specific to each customer, and only allow them, each user logged into Grafana, to see the dashboards that they're allowed. That gives you a way of filtering the data.
Yeah, so finally we can say that the Grafana will minimize the use of OpenNMS UI itself. In fact,
Yes,
I guess
that's right.
Yeah.
But
Yeah.
it also is more flexible in terms of building a custom view for a user. It's a lot more flexible. And the other thing, of course, is that you can actually create a view, and then you can generate a report in OpenNMS based on that view. So in that case, what OpenNMS will do is it will go to the Grafana dashboard, and it will take a snapshot of it, create a PDF file, and then email that PDF file out as a report. So instead of using Jasper reports in OpenNMS to build your own report, you could build a dashboard that represents the report you want to create, and then you can get OpenNMS to use that as the basis for reports that it schedules out to users. Which again is much more convenient and easier to configure than Jasper reports. Okay. So the other thing I wanted to cover, which we didn't get to the other day, was business service monitoring. And so business, now, would we like to take a little break for 5 minutes before we go any further?
Yeah, just to have a coffee. Yeah.
Okay, let's do that. So tell you what, come back in 10 minutes. So 10 past 10.
Okay.
And we'll stop there for now.
9 minutes to go. Okay.
Okay. Yeah.
Okay.
Okay, welcome back.
Yeah, Craig, I have a short question.
Yes.
Can I share 1 sec my screen, please?
Yes, certainly.
So that you will better understand my question. Can you see it?
Yes.
So this is more or less my my future test environment. So on the left, I have the minions, and I wanted to have. So as you can see, we have one minion location, location 1, and in there we have 2 minions. It was my initial plan, but unless I misunderstood what you said a few minutes ago, you said that we need to have 1 minion per location. So it would mean that this is this is what described here in my drawing is not possible, because I have 2 minions
that is possible
for the same location.
Yeah.
Possible?
So, yes. So the point is that if both of those minions will load balance between each other if they're in the same location.
Yes.
So yes, you can have as many minions as you want on a location, but obviously only one will be.
Only one will collect at a time.
Yes.
Okay.
And it'll share. It'll round robin. So basically, the minions sit on the Kafka queue and they wait for the next instruction, and the first minion to get to that instruction will do it, and the others will wait for the next one.
Okay. Okay. So finally, okay, I got it. One location per one active minion, I would say. Okay.
Well, one location per address segment in your network.
Okay.
Yeah.
Okay,
so that way you may have more than overlapping address segments or whatever.
So it means
you
that
more than 1 minion in each location.
Okay, so it means that in my case, minion 1.1 and minion 1.2 belonging to the same location, it means that these two minions will collect on the same address range, both.
Yes, they will.
Okay.
And they'll share the work between them.
Yeah, sure. Yeah, so that one trap will be collected by only one minion at a time, not by both.
Well, that's a different problem, right?
Ah.
So for collection where you're polling, where you're doing gets, then obviously only one minion will do the get at a time. But for traps, you need to have a load balancer in front of those minions to determine where the traps are going to go, because you only want one minion to receive the traps.
Exactly.
And if the other minion, is so just use one minion to receive the traps, but you can use either minion. So you could have a load balancer in front that would actually make them redundant. So if the trap comes in, it'll send it to one or to the other.
Okay, thanks. I unshare. Thanks, Craig.
Okay, any other questions before we carry on?
And what about minions which are not collecting the traps, which are collecting GMS, for example, data or something else? You previously showed us how to configure the alarms from the traps, but is there something similar for different types of data, or it's already enriched and it doesn't require such a configuration?
I'm not sure I understand. So we're talking about protocols other than SNMP?
Yeah.
Okay, so syslog would be a good example. You have to do a configuration for the syslog message to parse the message and get the data into the right form. That will then, be used to create events, and then events can be turned into alarms. So you still have the same process, but instead of starting with a trap, you're starting with a syslog message, and you have to parse that message to get the data you need.
And this configuration is also kind of the same process in where we done it, like an XML file or something like this.
Yes, but it's obviously different. The syslog messages.
And for example, we're starting collecting we wrote our own minion which starts collecting some data which was previously unknown for OpenNMS. How can we configure its mapping to alarms?
Well, I mean,
we should add something else like a plugin into OpenNMS which will describe translation of such an event to alarm, or
well, yeah, I mean, I don't, it's going to be different for every protocol. So I can't really answer that question. This, for instance, okay, is syslog messages, okay? So if you've got a source of events that are syslogs, then there are various parsers that you can use that will use Grok style parsing or other types of parsing that will turn the message into something that will generate an event based on the message. And then these, semantic tokens are obviously going to be the way to set this up. That will generate the message.
And therefore
need to create a UEI match that will actually generate the event based on the syslog, and the events then can be turned into alarms.
Same for a Kafka consumer, right?
Which
is upper in menu.
Consumer. Yeah, right.
Is it possible to add the different parsers?
Yes.
Okay.
And this notion of alarm is something like standard for an OpenNMS. I mean, some format which is standard for OpenNMS, to which we translate all the incoming events, right?
That's exactly right. So the alarm definition, the alarm definitions are going to be the same no matter what the source of the event is. Now, in terms of traps, obviously you've got the mask as part of the event definition, but for syslogs, you don't have that, right? You need to use this matching to create the UEI matches, and then, but what you will end up with is an event, and that event definition you'll put in OpenNMS will still have its reduction keys in that. So the event and the alarm definition will flow from having parsed the message from the syslog.
So basically, we will need to create an event from the data coming from syslog and then configure it the same way to make an alarm.
That's exactly right. So after that, the event and alarm processing is exactly the same.
And it's the same process for any different type of data coming, right? Like GMS or Kafka, right?
Yeah, well, okay. Yes. About short, yes.
Okay, thanks.
Okay. I mean, for instance, there's Kafka consumer here at consume events, but these are, again, these events will come in. You've still got to work out how you're going to do something with them. To be honest, I haven't got any material to talk about how to add new protocols into OpenNMS, because to a certain extent that probably is programming. Okay, you would create a new plugin for OpenNMS that managed this protocol, but ultimately what you would do is that whatever events that protocol supports would be translated into an OpenNMS event, and then the event and alarm system will run just as normal after that. Okay, let me just a couple of things. So I've uploaded this Regex 101 link, and this gives you an example of how I matched using this tool against the data for Nginx, and that gives me the groups. So that, so if you want a tool, this seems to work okay. Other tools are available, but this is what I used to do my matching. Okay, so that's up on session 7. So you can have a look at that if you want, if that's any use to you.
Okay.
Right. So let me now. What I wanted to do was to now talk about business service monitoring, which is I can never find it. Business services, right? Okay, so let's imagine I have a list of alarms here for the nodes. Remember my geographical display. I've got all of these nodes that represent cameras on the motorway. Supposing I said that I wanted to create a business service alarm that corresponded to a problem with all of the cameras at Chilworth. So here we've got, Chilworth is on the map, and I've got 2 cameras, well, 3, 4 cameras here at Chilworth. I want to create one alarm that summarizes all of the alarms underneath it to do with Chilworth. And perhaps I'd want to do that for other intersections on the motorway. So instead of having, lots of separate little camera alarms, I've just got a single alarm that says there's a problem at this location, or there's a problem at this location. Now, business service monitoring is a way in which we could do that.
Sorry, yes? Sorry, Craig, just to fully understand, you want to create a kind of aggregated alarm just to say that in that particular location,
yes.
1, 2, or even 3 cameras are getting problems, right?
Yes.
Okay. So it's okay. It's an aggregated alarm, in fact, that you want to create here.
Yes, that's correct.
Okay, sorry.
That's correct. Okay, so these are my cameras at my location. Camera 4, camera 5, 6, whatever, right? So I've got camera 4, 5, and 6. Now, if I go to my alarm, I've got an alarm here from camera 4. What I want to do is look at that alarm. Now, this alarm has a unique induction key associated with it. Okay, got health change 5. The 5 is actually going to correspond to that particular. Well, this is the UEI. Okay, so the reduction key. So what I want to do is I want to create a business service, and I'll go back to the business services that corresponds to that UEI. So let me create a new business service. I want to add an edge to that. Now, I could add another child service because I may have other child services I care about, but in this case, I'm just going to add a reduction key. And I'm going to add this particular reduction key here. Health change 5. Now, health change 5, if I just go back and have a look and see what it is, I know that this is a pan motor problem. Okay. So perhaps what I want to do is get all of the pan motor problems that would occur in different locations. Maybe I could do that, maybe not. But I'm going to just put in that.
What is the 5 here?
Well, the 5 actually is the
Varbind.
That's the extra varbind that's actually driving the trap.
Okay.
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 Now, I've just realized that this isn't quite going to work the way I would expect it, because actually, this is going to be specific to that edge. So let me just save that and see what it looks like. Chilworth alarms. Reload the daemon and let me have a look and see what that looks like. Oh. Unit topology. Okay. So you can see that Chilworth alarms now depends on this health change 0. And because I've used the reduction key, now unfortunately the reduction key is not going to be specific to a device. So in fact, I've got this slightly wrong. I can't use a reduction key in this case because it's not going to be unique per device. I don't think. Let me just check that and see if that's the case. I'm probably talking rubbish actually. Right. Okay. The 5, in fact, is camera 4. All right. So that's fine. So that is actually picking up the identifier for the camera. So that's okay. That's not a problem. Right. So I could actually do another one for health change for 4, which would be a different number. Let me just go back to the definition so you remember what it is. In a horizon here. I was confusing myself a little bit there, so I've confused myself. I've definitely confused you. So remember, we've got these event definitions. I'm just using the simple event definition in this case. So we've got a raise alarm here, a health change raise. And if you look at the definition for the reduction key, you can see it's using parameter 2. And parameter 2 in this case is well, it's the node ID is actually going to be the thing that's important for this. So we've got the node ID and we've got parameter 2. So it's definitely it's going to be still a unique to a particular type, but it's also going to be unique to a particular camera. So so health change 5 and then 0. So the 5 is actually the camera. The 0 is the particular health change problem we've got. So we're only going to be interested in pan motors. We're going to be interested in node 5. So let me just take this and apply it to a different node. At the edge, friendly name. I'm on a call, David. I'm going to add another edge. And in this case, again, this reduction key is going to be, I'm going to change that to 4.
So
and
4,
I'm just going to check.
4 is another camera, right?
It's a different camera, yeah. So I just need to get the nodes. So if I just go back to the nodes, let's just look at the, so camera 3, 4 is the, you know, camera 2. So that's camera 1, that's camera 2.
Yeah, 4,
so it's
4
different
is
cameras.
4 is the internal ID.
It is the internal ID.
From Postgres DB.
Yes, that's right. Okay. So again, if I go back, this is 4, so it's a different camera. Let's see what camera it is. It's camera 2. Okay. The edge, I'm going to I don't know what camera it is, but it doesn't matter. Let me see.
3. Camera 1 is 3.
Yeah, it's going to be 3. Yeah. Okay. Right. Well, it's going to be camera 5. So what is 5? Oh, 4. Camera 4. Okay, good. Right. Okay. So I've got 2 edges. Save that. Reload the daemon. And then view in the topology UI. And you can see that we now have, you know, this Chilworth alarms. Camera 2's got no problems. Camera 1's got a problem. Camera 4's got a problem. So let's try and get rid of this.
So basically, Craig, this is a logical map in that
That's right.
case.
It's a way of relating services.
Okay.
Now I'm using reduction keys to give you a unique identifier for each of the services. But you can also use actual services in OpenNMS. So if you're polling, for instance, HTTP or ICMP.
No, that's clear. So for my colleagues, it's like Neo4j in that case. You know?
Okay.
Yeah. Neo4j and UCA, right? When you define a model for correlation.
Yes, I think we can compare. Yeah, that's the same logic.
But it's very interesting that you can produce
it's a topology graph, in fact.
Exactly.
That explains
logical.
how the basic alarms will impact the upper service.
Exactly. You can also put different ages in terms of alarms, right? You know, so different alarms also. But anyway.
Yeah.
That's right. So if I go back to this display, think I've cleared out the alarms.
What can be interesting is how to define properly child port alarms also.
I'm sorry, say again?
No, if we can specify better with measure information child port alarms, for example, this is something we can put a sort of additional text there that to produce.
You mean we can enrich the child word for alarms?
Yes, exactly.
Yes.
So we can have, that's very interesting. Yeah. Because it's a level of correlation that you can take advantage already.
OpenNMS can do that, probably this enrichment, I guess.
Without attributes.
Okay, so anyway, this is business service monitoring. It just gives you an idea. You can have a hierarchy of underlying edges. You can build quite a complex graph. This just gives you an idea of how that can be done and what it looks like in the UI. Okay.
How is the child port alarms? How it does look like?
Sorry, the what alarms? I don't hear you. What sort of alarms?
No, child port alarms. How it will be appearing? Which is the reduction key of child port alarms?
Okay, all right.
How it was?
Let me look at the events.
This one, yes.
Yeah,
okay.
Business service childbirth alarms. There we go. So it's a service problem alarm.
Mm-hmm.
So business service monitoring. It's going to be specifically, again, you may need to do more work to actually create a specific alarm associated with this. But you can see that you've got a UEI associated with it. Service problem resolved, service problem created. You can attach a severity to it. There's still more work to do to make this into what you need it to be, but you can see that the business service problem, has changed.
Yeah.
So we're creating a new set of alarms related to that business service problem based on this definition.
Okay.
But this is a whole topic in its own right, and we'd probably have to spend quite a bit more time on it to go into all the details. But I just wanted you to be aware of this.
Yeah.
The other thing I wanted you to be aware of was Drools and how Drools works, which is another rules engine. So this engine is, users can make this work quite simply, as you can see. It doesn't require any programming. It just requires you to know what reduction keys are important to you or what services are important. You can build a graph out of that. Drools is much more complex and it does involve a certain amount of programming, but you can do many, many more sophisticated things with it. So what I wanted to show you finally was, if I go back up to my pristine config files and look at my etc file, and I want to look specifically at this alarmd Drools rules set of files. These are rules that OpenNMS uses automatically itself to create and change the state of alarms. So whenever an event comes in, it uses these rules to change the state of an alarm based on these rules. And you can add extra rules files into this folder, and those rules will all be registered in the rules engine and will also apply. How they interact with each other, you've got to really test and make sure that they work fine. But I just wanted you to be aware of the rules folder. Now, this is a standard rule that comes with OpenNMS that you wouldn't normally need to modify, that allows us to, that basically manages the alarm lifecycle. Yeah.
I have the experience for this, for clearance, counseling, whatever. Yeah. Also for the maintenance of the database of the alarm.
Yes. So you can see here that there are various different rules here in terms of escalation, cleanup, full cleanup. Some of it's made a little bit more complicated because we don't want to delete alarms for which there are outstanding trouble tickets. But, that's a bit of extra complexity, really. That's specific to tickets. If you're not using tickets, it doesn't matter. But in terms
there
of
is no UI to specify this.
There is no UI. This is programming. This is Drools rules. Now this is a standard.
So is it some internal language or it using some kind of,
no, it's using
Groovy
rules, no, it's using rules. So it's called JBoss rules.
Okay. JBoss, yes.
So JBoss rules, same thing. That's what we're using, okay?
Actually, so they have a UI.
This is what we have in our code.
But it's pretty limited and it's doing what it's doing. It's not really,
we need to program via Eclipse environment probably.
Yes, you do. I mean, to do this properly is, it's programming. There's work to do. But you can see really, this just gives you this example, this cosmic clear, when the session clock, so basically it's waiting for a tick, basically something's happened. Then it's going to look and see if there is an alarm type that's a clear alarm type. So resolution type is type 2 alarm. So if there is an OpenNMS alarm of type 2, which is clear, and if the alarm type is so this is the other alarm. So if we've got another alarm that's got a problem that's of greater than severity normal, and if the reduction key equals the clear key, and if the last event time is less than this event time, so we don't want us to fire again and again and again, it just fires once, then we're going to clear that alarm. So what this rule is doing is it's implementing how OpenNMS clears alarms. It's sitting and waiting for an alarm to come in that is a resolution alarm, let's say type 2 alarm. If it sees a type 2 alarm, then it will check if there is a type 1 alarm that has the same reduction key, the clear key. And if it has the same clear key, and if we've not already dealt with it, so this is what the event time is about, then it will clear that alarm.
But this is done normally by default by OpenNMS.
This is how OpenNMS does it.
Okay.
Right. So these are the standard rules in OpenNMS that cause it to implement that alarm lifecycle.
Okay.
So don't change them unless you know what you're doing.
Yeah. It was my point.
But the point is that you can add extra rules in. You can create if any files that are in the rules directory will be run as rules. So you can create a separate set of rules that will act as, that you can do specific things with. And I do actually have some example rules that change the severity of alarms based on who the customer is associated with a particular node. I haven't got that example for you here, but there are various ways you can do this. But I wanted you to be aware that this is how OpenNMS deals with alarms, and that there's a lot of power here. You can be very sophisticated in what you do, but with a lot of power comes a lot of responsibility. This is much more like programming than doing something with a UI. So you do need to practice if you're going to try and do something with this. But the beauty of it is, if the rule breaks, you can take the rule out of the directory, and OpenNMS will go back to normal. So if you are trying something for a particular customer, you haven't actually broken OpenNMS. But you do need to be careful, because you can introduce memory leaks and other problems, and also race conditions that you may not expect when it's running, when you've got a huge number of alarms in the system. So if you're going to do something with this, you do need to make sure you do a lot of testing.
Is there any sequence of rules if we, for example, we do some processing in one rule, and then we expect that second rule will do the other things?
So you can chain rules. So you would effectively, as a result of a rule, you would assert another fact, and then the second rule would listen for that fact, and then it would work based on the fact that you've created. The salience, this number here, also can be used to determine the order in which rules fire. So if there were two rules firing at the same time, the one with the highest salience will fire first.
Okay.
But this is a topic on its own right. I mean, you could be
So the second one, which will be fired next, will receive not the initial data, but data after the first one processing, right?
Yes.
Mm-hmm.
I'm just wondering, do we have possibility to trigger some action directly from the alarm? For example, if alarm is received.
What you could do is from an alarm, you can actually create an event. So the alarm service has got the ability to create an event. So what you would do is, having done your processing, then you would actually fire an event, and then you'd use that event to drive other behavior.
Yeah, but if I want just to trigger a script, for example.
Yes, so that event would trigger a script. So I should also show you.
But it should be done with rules, right?
Well, I wouldn't use the rules to do the script. I would use the rules to determine the script should run. There is actually another thing I should show you. Edit, find page scripting. Script-D is, well, this isn't a good example. Let me see if I can find the examples. Yeah. So here is an example using, so script-D runs on events, okay? So what this is doing is it's basically listening for events, and on a particular event, it is forwarding that event using that script-D event forwarder. Now you can specify what events script-D is going to listen for, but essentially what happens is it listens for events. When an event comes in, it runs this event script. It looks up the event and it does something with it. In this case, I'm actually going to forward to a script. Now, this script is written in Bean Shell. It can be written using Groovy. And we can see what this actually is doing is it's generating a new trap and forwarding the trap. So what this example would do is for every event that comes in, we will create a trap and we'll send the trap out of OpenNMS to the remote location that we've specified, which is this 172.1.11. And the trap will contain these particular fields.
But this is impossible to add trap into specific alarm configuration. For example, if I want to get to run automation script from some specific event. So it's not possible to add into event configuration XML such.
It is. There is a way of doing that, but this is much better to do than that. There is a script field within event definitions that can be used to fork a script, but we don't recommend you do that because it has quite an impact on event-D. So it's much better to use the script-D system, which is going to be listening to the event bus. And then you can choose what events you want to listen for, and you can choose what script's going to run based on what event. And you use this script-D configuration to do that. So you can see the script configuration basically tells us what engine. It's using Bean Shell. It tells us, at the startup, these are the things you want to do. You want to basically load in the script itself. And then on event, every time you get an event, you want to run that particular procedure that's in your script. And in this case, that procedure is going to send out a trap, but it could do anything you want.
Okay, thank you.
Okay, so that was a bonus. So we've done a little bit about script-D. We've done a little bit about rules. We've just whet your appetite in both of these because they're quite complex. We've done a bit about business service monitoring, which allows you to create new alarms based on an underlying graph of alarms. We've looked at Nginx. We've looked at data collection from Nginx and how to put Nginx in front of OpenNMS. And yes.
And this script configuration XML file, we should put it at the right place, I guess, in the OpenNMS container. I guess we have to put it in a specific folder. probably.
You put it actually in just in the etc directory. So
Okay.
you'll see in this pristine etc directory.
Okay.
You know, scripty. There is actually.
Yeah, I saw it. I saw it. Yeah, I saw it.
It's not doing anything, you know, but that's where you would put it.
Yeah.
The only thing I would say is very important for scripty is you want to return quickly from your method. You don't want this to be a long running thing. So for instance, I've had to create a REST call based on an event. What I've actually done is used the asynchronous asynchronous HTTP client from Apache, which is already in the class path. And I've used an asynchronous call to make a REST call so that the event comes back straight away. So basically the event script runs, you make an asynchronous call that can run in a separate thread, take however long it takes, and then finish. Don't try and do long running calls to a REST API from the event script directly, because you really want the event script, the event to be handled very quickly and then return. You don't want there's something that's going to delay how long it takes to return, because that will slow up all of the event system in OpenNMS. But this is a topic in its own right. I mean, we could spend another session on event-driven management using scripting and the like.
So, Greg, do I understand correctly that we can have our own custom minion, or maybe you already have one, which is monitoring the OSGI components inside of the core OpenNMS process, and in case it is getting some trouble with some of them, we can run the scripts to restart part of the core process, not restarting the Docker container itself with these scripts. Through GMX, for example, I don't know.
Yeah, I'm not going to say yes or no. It's a matter of programming. I'm not sure if it's a good idea or not. But yes, you can. You mean we do already monitor using JMX the processes in OpenNMS.
Okay.
You know, so if I mean, I'm not sure if we're actually picking it up or not. But let me just go to the nodes and see. Horizon, we probably are. No, it's not right. So let me localhost. Yeah, so we're picking up JVM here, yeah. Right? So if I just look at the resource graphs we're picking up for this, you know, there's stuff coming from Event-D, Postgres, QMetrics. This is all coming from JMX, and it's all specific to OpenNMS. So there's a lot of data that's coming in from OpenNMS. You know, database count, all that sort of stuff. So yes, so the data is there. Okay. You could collect the data, you could threshold on it. Whether or not you'd want to automatically restart a process, I would hesitate to say. I don't think necessarily that's a good idea, but you know, it's up to you.
And there are few types of the deployments of OpenNMS. You told us about the Docker one, and I guess there's something like monolithic one without Docker, not Dockerized. And in this case, it makes more sense in having such an ability to go inside of OSGI container and work with the services inside, because we cannot restart it like a Docker container.
Yes. Yeah.
What's the unit from the Y axis? Alarms is expressed when we see average 2.72. What does it mean? What's the unit?
Well, I mean, the units, I mean, I don't know why it's giving you points, but basically this is number of alarms. So, you know, we've got maximum of 5 alarms. Probably because it's just averaged. It'll probably be 7 alarms. but it's just averaged over a time period. So that's just the way the graph's done. But
so that's giving the number of alarms collected per second.
No, it's giving the number of alarms that were in the database at that point whenever we pulled it.
Okay.
Okay, so we're regularly polling every 5 minutes. At every 5-minute interval, we're saying, well, we had 5 alarms here, we had 4 alarms there, we had 3 alarms. So it's just giving you a count of the number of active alarms you actually have at any point in time.
Okay. Okay. Yeah, it's not really useful. Okay.
Well, no, it might be useful. Who knows? Somebody needed it. That's why they did it. I mean, what it will tell you is whether your alarms are going up to a ridiculous number and you're not clearing them, because ultimately there's a penalty if you've got hundreds of alarms in the system.
Yeah.
So anyway, that's all I have really for you, and pretty much at the end of time as well. Are there any sort of last questions that people have before we end the session?
Yes, yeah, Craig, I have a question.
Yes.
So basically, when we are deploying Minion and OpenNMS core in a Kubernetes cluster, what are the factors we have to consider for sizing the pod, like resources, CPU or memory, whatever we are going to assign?
We have 5 minutes left. We're not going to.
Craig, the material that you shared will be available also in the next days, of course. Sorry for maybe a silly question.
Yes, it's all available on GitHub already.
Okay.
Okay.
And it remains.
Yes,
there.
it's not going to go away. It's a tutorial. It's going to be used, available to everybody.
And,
thank you.
And also, Craig, the goal is not to disturb you too much, but can you please share your email address just in case of we would have a one
Absolutely.
question.
Yeah, that's no problem at all. Paul, we've actually, and I know Natalie was on the call. I'm not sure she's on now. We want. Yeah, I'm just going to share my email address in the chat. We realized that there's an awful lot of material here, and there's probably still a need for you to have help revising it, going through it again, and whatever. And I think what we've talked about with Paul is the possibility of maybe doing a monthly session or something like that. That would actually just move things along.
And in parallel of what you are doing, just to be back to Sanjaya question, of course, we don't have the time to. You don't have the time to handle this question about pod sizing, for sure. But at least, can you please share one or two interesting links that can give you that can provide some guidance to try to size the OpenNMS.
Honestly, Eric, I can't. I don't have that information. You're going to have to ask Marshall, because he's been the person who's been responsible for all of that Kubernetes work.
So to ask who?
Marshall Messingill. Basically, raise it as a ticket quest, and they'll give you that. But that's really something to raise through support. I don't have that information. There's no easy answer for that, I'm afraid.
What's his name? Is Marshall? Sorry,
Marshall Messingill. Just raise a support ticket.
Okay.
You also mentioned the troubleshooting guide. Can you point us to this document?
Same thing. Again, the support guys do actually run a course, or at least a session workshop on how to do troubleshooting.
I mean, maybe there is some high-level guide available from community.
Just what you find on Mattermost. So the OpenNMS Mattermost server is where a lot of questions get raised and answered. that would really be the place I would go if you've got a specific question, first of all.
Thanks.
Okay. Thank you very much.
Greg.
Okay.
Thanks a lot. Yeah.
So yeah, just
Grazie.
before we go, can I just ask whoever took the recording from yesterday, you've shared the link with me, but you haven't allowed me permission to get that link. So if you could,
I already allowed the request. So you just check it. Can you check it? I can.
Yeah, I'll check it now. Thank you. Great. But other than that, folks, thanks very much. You've been a great class. Lots of really good questions, and I've enjoyed it at least. I'm very sorry about all the problems we had earlier on, but hopefully we've recovered, and we've certainly covered all the material we're going to cover. We may have done it a little bit quicker than I would have liked, but hopefully going back through the videos and doing the exercises, you'll be able to find that. I'm just going to see if I can find the folder.
Okay. Bye.
That's great. I've got it. Thank you very much.
Bye.
Okay, folks.
Thanks a
Thank
lot.
you. Appreciate it.
Bye.
Cheers. Bye.
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 Thank you. Bye bye.
Thank you very much.
Thank you. Bye.